Welcome students. This is the first video of crash course for the students of class 10th board examination. These videos are very useful for them, and we are trying to discuss all the important concepts of the chapters, including important questions asked in previous years. So you will be very much benefited with these videos. So keep watching these videos. Here we are starting this first video with the first chapter of standard 10, which is real numbers. So first of all, we'll start with the introduction of real number, and we will discuss also how to solve the problems and what are important aspects, important definitions, important terms in these chapters. So let us start with real numbers. So what is a real number? Let us first try to understand it. What is a real number? So a group of real numbers, the entire group, entire set of real numbers can be divided in two groups. One is rational number. Rational numbers, and another group is irrational numbers. Irrational numbers. And as we know that the numbers which can be expressed in the form of p by q, in the form of p by q, where q is not equal to 0. These are the standard form, general form. If a number can be expressed in this form, the number is a rational number. As for example, suppose you write 5. This is nothing but 5 by 1. So this is a rational number. If you write 3 by 7, this is already in the form of p by q. So this is a rational number. Suppose you write 0.5. So 0.5 is nothing but 5 by 10. This is equal to 1 by 2 in the form of p by q. So there are so many examples of rational numbers, correct? And irrational numbers, in fact, we can define irrational number which is non-terminating and non-repeating numbers. Irrational numbers are those numbers which are non-terminating and non-repeating. Numbers are known as irrational numbers. Okay, suppose we write 3.01000100001 and so on. You see the pattern. Okay, dot means this is non-terminating. This is non-terminating, and this is non-repeating also. How? Because after 1 0, 1 is there. After 2 zeros, 1 is there. After 3 zeros, 1 is there. So this pattern is already going on here. So this is non-repeating and this is non-terminating. So this is an example of irrational number. All square roots of the numbers which are not perfect square are known as irrational numbers. As for example, square root of 2, square root of 3, square root of 5 and so on. These are irrational numbers. Pi is also an example, is irrational number. In fact, we write pi is equal to 22 by 7, which seems that this is a rational number because 22 by 7 is in the form of p by q. But we should know that that is not the absolute value, that is the approximate value of pi. In fact, pi is non-terminating and non-repeating number, so pi is also an irrational number. There are infinite irrational numbers as well as we are having infinite rational numbers, and the entire group of these rational numbers as well as these irrational numbers form a bigger group of real numbers. Correct? Very interesting. Okay. Now we will discuss prime numbers. What are prime numbers? Prime numbers are those positive integers which are having only two factors, 1 and that number itself. Means prime numbers are divisible by only two numbers. These two numbers are 1 and the number itself. Correct? So, prime number are those numbers, and compulsorily these are positive numbers. No prime number is negative. Okay? So, prime number are those numbers which are having only two factors. Having only two factors. Okay? One and the number itself. As for example, suppose you take any number, suppose 13. Then this number 13 will have only two factors. Only two factors. These are 1 and 13. Means this number 13 will be divisible by either 1 or 13. Means divisible by both 1, 13 or either or. Okay, correct? So it means there is no any third number other than 1 and 13 which can divide 13. Very simple. So from the beginning, prime numbers are 2, 3, 5, 7, 11, 13, 17, 19, 23 and so on. In total, how many prime numbers are there? Infinite. Set of prime numbers is an infinite set. Infinite prime numbers are available. Correct? Now let us see composite numbers. Those positive integers which are not prime numbers are composite numbers. As for example, in the list of these prime numbers, 4 is not here. Means 4 is not a prime number. So 4 is a composite number. So either that positive integer will belong to this group, prime number, or that number will belong to this group, composite number. So either positive integers are prime or composite. There is no such number which is common in both the groups, in prime and composite. Okay? So composite numbers are having minimum 3 factors. Minimum 3 factors. It means other than 1 and the number itself, there is one more factor, minimum. Minimum. Okay? Maybe more than 3 also. So let us take an example. Suppose you are taking 50. So what are the prime factorization of 50? This is 2 into 5 into 5. Okay? So 50 is divisible by 2, by 5, other than 1 and 50 itself. Correct? So 50 is a composite number. Okay? Now let us discuss prime factorization. You know, prime factorization method is very useful for finding HCF and LCM of 2 or 3 or more than 3 numbers. So prime factorization of composite numbers. Let us make it clear with the help of example. Suppose we are taking 60. Then this 60 can be factorized. We can break up it in form of prime numbers like 2 into 2 into 3 into 5. All these numbers are prime numbers. So this number 60 has been factorized in different prime numbers. So this is called prime factorization of this number 60. Interesting, very simple. Okay. Now let us see what is HCF. You know HCF is highest common factor. Highest common factors. So how to get HCF? HCF of two or more numbers is the product or multiplication is the product of minimum power of common prime numbers. As for example, suppose you have to find out HCF of 4 and 30 is how much? How to get HCF of 4 and 30? First of all, we will write prime factorization of 4 and 30. So prime factorization of 4 is 2 into 2. This can be written as 2 square also. And prime factorization of 30 is, this is 2 into 3 into 5. Here power of 2 is 1, here power of 3 is 1, here power of 5 is 1. So we are here talking about product of minimum power of common prime numbers. So 3 and 5 are not common. 3 and 5, these primes are here in 30 but not in 4. Isn't it? So common prime number is only 2. So you have to take product of minimum powers. So which one is minimum power? This one, 2 to the power 1. This is minimum power. So HCF of 4 and 30 is equal to how much? 2. Correct? We have to take minimum power of common prime numbers. So only 2 is common in prime factorization of these two numbers 4 and 30. And we have to take minimum power, isn't it? So we are taking 2 to the power 1. We are not taking 2 square because this power is bigger than 1. So 2 to the power 1 means 2 is the HCF of 4 and 30. Now let us see LCM. Full form of LCM is least common multiple. How to get LCM? LCM is product of maximum powers of each prime number available in the numbers. So if you find LCM of 4 and 30, how we can get it? First you do the prime factorization of 4 and 30. So you have to take maximum powers of each prime number available. So this is 2 square, this is 2 power 1, so this is maximum, so we will take 2 square, means 4. Into, we have to take each prime number. Another prime number is 3 here and 5 here. So into 3 into 5, this is equal to 60. This is the LCM of these two numbers, 4 and 30. Correct? Now one very useful formula based on HCF and LCM that we will apply in solving questions, and such type of questions are generally asked in board examination also. The formula is HCF of two numbers or more than two, but in this formula we have to take only two numbers, cases of two numbers, because this formula is not applicable for more than two numbers. So HCF into LCM is equal to first number into second number. Let us check it. 4 and 30, we have taken two numbers. So in this case, in this particular case, HCF of 4 and 30, we have got 2. And LCM is how much? We have got LCM is 60. So this is left hand side, HCF and LCM. And right hand side, 4 and 30. So you see, both the sides we are getting 120. So this formula is being verified here. LHS is equal to RHS. So you have to remember that HCF into LCM is equal to first number into second number. In most of the questions, we will find that out of these four quantities, which four quantities? HCF, LCM, first number and second number. Any three will be given. And we have been asked to find out the fourth one. By putting three given numbers here in this formula, you can get the fourth number very easily. So this formula is being verified here. So these are some very basic concept of this chapter, real numbers. And most of the time, I can say almost all the time, questions have been asked in board examinations based on these concepts of this chapter. This question is related with HCF of two numbers. Question has been asked in the year of 2018. Question is, what is the HCF of the smallest prime number and the smallest composite number? Okay, so we know smallest prime number is equal to how much? Yes, 2. Smallest prime number is 2. And the smallest composite number is 4. Yes. And the smallest composite number is equal to 4. So what we have to find out? We have to find out HCF of 2 and 4. That we have to find out. So before finding HCF or LCM of two or more given numbers, what we do? First we do prime factorization. So this 2 is already a prime number. This is 2, or simply you can write 2 to the power 1. And this 4 is 2 into 2, or we can write 2 square. So how to get HCF? We take the smallest power of common factors. So out of these two numbers, the smallest power is 1 here. Here 2 to the power 1, here 2 to the power 2. So smallest power is 1. So we take this one 4. Therefore HCF of 2 and 4 is 2. This is the answer. Very simple, very interesting. But you must keep in mind that the smallest prime number is 2 and the smallest composite number is 4. Then we can find out HCF of these two numbers 2 and 4 very easily. Now we'll see next question. Question is, if HCF of 65 and 117 is expressible in the form 65n minus 117, find the value of n. Question has been asked in the board examination of 2019. So let us see. Solution is very simple. Here two numbers are 65 and 117. First of all, we'll try to get HCF of these two numbers by prime factorization method. So what are the prime factors of 65? Yes, this is 5 into 13, correct? This is prime factorization of 65. And prime factorization of 117, it is divisible by 3. 3 into, when we divide 117 by 3, this is 3 3s are 9, 3 9s are 27. 39 is again divisible by 3 and 13. Okay, so this is 3 to power 2 into 13. So HCF of 65 and 117, we know how to get HCF. Multiplication of minimum powers of the numbers. So here 5 and 13, here 3 square and 13, so 13 to the power 1, here also 13 to the power 1. So we will not take 5, because if this is 5 to the power 1, we can suppose here 5 to the power 0 also. So we are not taking this 5. Similarly, we are not taking 3 square, because we can multiply this 3 to the power 0, that is 1. So 3 to the power 0 is the minimum power. So we have to take 13, which has power 1. Okay. So HCF of 65 and 117 is 13. Correct. Now here mentioned that HCF of these two numbers is expressible in the form of 65n minus 117, and we are getting this HCF is 13. So we can find out value of n very easily, or 65n is equal to 117 plus 13 is equal to how much? 130. So therefore n is equal to 130 divided by 65, this is equal to 2. So we are getting value of n is 2. This is the answer. Here we had to find out value of n, and we are getting value of n here 2. Very interesting. Okay, hope you have understood it. Now let us see next question. Here question is, given that HCF of these two numbers 135 and 225 is equal to 45, find the LCM of these two numbers 135 and 225. Question has been asked in 2020. Very interesting questions. We know the formula that LCM into HCF of two numbers is equal to product of numbers, multiplication of numbers, means first number into second number. Okay, here we have to find out LCM, and HCF is already given. This is 45. First number is 135 and second number is 225. So therefore LCM of these two numbers 135 and 225 will be how much? 45 will be transposed to right hand side. So this is 135 into 225 divided by 45. Simplify it. When you multiply 45 with 5, we are getting 225. So multiplying 135 and 5, this is 675. 5 5 are 25, 5 3 are 15 and 2 17, 5 1 are 1, 5 1 are 5 is equal to 5 and 1 6. So we are getting LCM here. LCM of 135 and 225 is equal to 675. This is the answer. Very interesting. Question is very important. Next question now we will see. Very interesting question. Question is, can two numbers have 15 as their HCF and 175 as their LCM? Justify it. Question has been asked in the year of 2017. Correct. So let us see the solution here. Answer is no. And what is our justification? We know that HCF is always a factor of LCM. HCF is always, or you can write must be a factor of LCM. But in this case, here 15 is not a factor of 175. If you factorize 175, then this is how much? Divide 5, 5 3 ja 15, 5 5 ja 25. Okay, so when you divide 175 by 5, 5 3 ja 15, 5 5 ja 25, 5 into 35, so 5 into 7. So factors are 5 into 5 into 7. We are not getting here 15 as the factor of 175. But we know that HCF should always be a factor of LCM. So since 15 is not a factor of 175, so therefore 15 is not HCF of two numbers as their LCM is 175. So answer is no. Correct? And this is the justification why 15 is not HCF of two numbers having LCM 175. Very clear? Okay. Let us see next question. Here question is, check whether 4 to the power n can end with the digit 0 for any natural number n. Question has been asked in 2015 board examination. Okay, try to understand the question. Ending with the digit 0 means, suppose we write 350, ending with 0. Suppose you write 190, ending with 0. Suppose you write 200, ending with 0. Suppose you write 50, ending with 0, and so on. So here question is, check whether 4 to the power n can end with the digit 0 for any natural number n. N may be any natural number. So here given number is 4 to the power n. This is 2 square whole to the power n. This is 2 to the power 2n. So our concern is that whether this number is ending with 0 or not. Answer is no. Answer is no. Not ending with 0. And what is the justification? Because for ending with 0, there must be a factor 5. So that 2 into 5 is equal to 10. Then only we will have a digit 0 in the right hand side, means ending with 0. But here 2 to the power 2n is nothing but 2 into 2 into 2 into 2 into how many times? Yes, 2n times. There is no 5. There is no 5 as a factor. So without being 5 here as a factor, we cannot get 0. So since there is no 5 as a factor, so therefore 4 to the power n cannot end with 0 for any natural number n. This is our comment. This is our answer. Hope you have understood it. Because without 5, we are not getting here 10, means 0 as a last digit. So this is not possible here. This is our comment. Hope you have understood it. Let us see next question. Here question is, after how many decimal places the decimal form of a given rational number will terminate? Is this question clear? We'll make this question very clear. This is very simple. So first of all, let us try to write the answer. Then we will make it more clear with the help of some examples. So here it has been asked that after how many decimal places the decimal form of a given rational number, talking about rational number, will terminate. So you know that rational number can always be expressed in the form of p by q, where p is numerator and q is denominator. So for any rational number, we'll try to factorize the denominator first. Okay. So solution is that denominator has to be factorized first. Okay. If denominator is having only 2 and 5, only 2 and 5 or any one, either 2 or either 5 or both, then only the rational number will terminate after some places of the decimal form. And if any other factor other than 2 and 5, suppose 3 is a factor in denominator, or even 7 is a factor in denominator, or 11 is a factor in denominator, then this fraction number will be non-terminating. Decimal form will not terminate. That will remain continued. Okay. So denominator has to be factorized first. So let us suppose that denominator is factorized as 2 to the power m into 5 to the power n. Okay. So there may be two cases. If m is greater than n, then decimal form will terminate after m is greater, so after m places of decimal. And if n is greater than m, then decimal form will terminate after n places. Simple rule. Okay, example. Let us take some example to make it very clear. One thing I would like to add here, that if there is any other factor, if any factor of denominator other than 2 and 5 exists, like 3 or 5 or 7 and so on, the rational number will be non-terminating. Non-terminating. Non-terminating means decimal form will not terminate. That is, decimal form will not terminate. This is additional information. Otherwise, this much answer is complete. Okay. Let us take some example. Suppose you write 3 by 2. Okay. So after dividing, this is 1.5. How we'll understand? Here 3 by 2 is 2 to the power 1 into 5 to the power 0. 2 to the power m, 5 to the power n. M is greater. In place of m, we are getting here 1. Here we are getting m is equal to 1. So after one place decimal, after one place of decimal, this number is terminating. Decimal form is terminating. If you take 3 by 4, this can be written as 3 by 2 square. You can write 5 to the power 0 also. Here m is 2, n is 0, 2 is greater than 0 here. So decimal form will terminate after 2 places. What is the value of 3 by 4? 3 by 4 is equal to 0.75. So after 2 places. Suppose you take one more example. Suppose you take 3 by 250. How denominators can be factorized? This is 3 by 2 to the power 1, 5 to the power 3. Here power of 5 is greater, means n is greater. Value of n is 3. It means after 3 places decimal form will be terminated. And what is these 3 places? You find out this value. 3 by 250. 3 by 250 is equal to, you divide it, 0.012. So after 3 places decimal form is being terminated. So these are sufficient examples to understand that if denominator has been factorized and factors are in the form of 2 to the power m, 5 to the power n, and if m is greater than n, then decimal form will terminate after m places. If n means power of 5 is greater than power of 2, then decimal form will terminate after n places. We have to look at the greater value among m and n. Correct? So this is the answer and these are examples of this question. Clear? Okay. Now let us see next question. Here question is, prove that root 3 is an irrational number. Question is very important question. It has been asked in the year of 2020. In examination we will find that in place of root 3, maybe root 2, maybe root 5, maybe root 6. Pattern will be same. Okay, we have to give the answer in the same pattern. So let us see how we can solve this question. Here we will prove this question on the basis of contradiction, on contrary basis. Contrary basis means, first of all, we'll suppose that root 3 is not an irrational number. Okay, first we will suppose it. On contrary means contradiction basis. On contrary, let root 3 is not an irrational number. It means we are assuming first that root 3 is a rational number. That is, let root 3 be an rational number. So by the definition of rational number, we know that every rational number can be expressed in the form of p by q or a by b, whatever you like, okay, in the form of numerator by denominator, in smallest form. So therefore let root 3 is equal to a by b, where a and b are some prime numbers. You can say a and b are co-prime, and there is no factor is common in a and b. There is no factor common in a and b. That is, a and b are co-prime. Co-prime means both are prime numbers, no factors are common in this case. Okay. So first of all, we are supposing that root 3 is not an irrational number. This is a rational number. So after this wrong assumption, you will get some wrong result. That will mean that our assumption is wrong. So our correct assumption will be root 3 is not a rational number. It means root 3 is an irrational number. Okay. So let us proceed. Here root 3 is equal to a by b. So squaring both sides. 3 is equal to a square by b square, or a square is equal to 3b square. What does it mean? It means that in right hand side 3 is a factor. Means left hand side is also having 3 as a factor. Since LHS is equal to RHS, means left hand side is divisible by 3. Isn't it? 3 is a factor here. So you can write here as 3b square is having 3 as a factor. 3b square means right hand side is having 3 as a factor. What does it mean? It means a square is also divisible by 3. If a square is divisible by 3, it means a is also divisible by 3. Then only a square will be divisible by 3. That is, a is divisible by 3. So let us suppose a is equal to 3 times of some number c. A is equal to 3c. If a is divisible by 3, it means a is having 3 as a factor. So let us suppose a is equal to 3c. Now putting this value here, let us write equation number 1. So putting a is equal to 3c in 1, we get a is 3c, so 3c whole square is equal to 3b square, or 9c square is equal to 3b square. Dividing both sides by 3, we are getting 3c square is equal to b square. So in this case here, 3 is a factor in left hand side. Here 3 is a here 3 is a factor in left hand side. What does it mean? It means b square is divisible by 3. That is, b square is divisible by 3. Or we can say b is also divisible by 3. If b square is divisible by 3, this is possible only when b is divisible by 3. That is, b is divisible by 3. Let us see these two cases. Here we are writing a is divisible by 3. Here we are writing b is divisible by 3. It means a and b both are having 3 as a common factor. That is, a and b both are having 3 as a common factor. Okay. So if a and b both are having common factor, then writing this statement, root 3 is equal to a by b, there is no factor common in a and b, there is a contradiction. Here we are writing that there is no common factor a and b. Here we are getting the result that a and b both are having 3 as a common factor. Why we are getting this wrong result? Because our assumption is wrong. Because we have assumed that root 3 is not an irrational number. So this contradiction shows that root 3 is an irrational number. Okay. So this contradiction shows that root 3 is an irrational number. Proved. We are getting the result here. Very interesting, very simple. Question is very important. So try to write yourself thrice, 4 times, 5 times, so that you would have a good command over this question. Question is generally asked, this type of question in board examination. So hope you have understood it. Now we'll see next question. Here question is, show that 3 into root 7 is an irrational number. Question has been asked in the year of 2016. Question is very important. Sometimes question may be asked as 3 into root 5 is an irrational number, or 2 into root 3 is an irrational number. Pattern of the question may be changed, but pattern of solution will remain same. So minimum one question will be asked of this pattern in your board examination. So let us see the solution. Here we have to prove that 3 into root 7 is an irrational number. What is irrational number? A number which is non-terminating and non-repeating. Non-terminating and non-repeating, which cannot be written in the form of P by Q, cannot be formed in the rational number. So this is non-terminating and non-repeating number is known as irrational number. So here we have to show that 3 into root 7 is an irrational number. We'll prove this question first of all with the help of contrary basis. Contrary means contradiction. Means we have to prove that this is irrational number, but on contrary we will suppose first of all that this is not an irrational number, this is a rational number. And we will see later on that by this wrong assumption that 3 root 7 is not an irrational, this is a rational, this is wrong assumption, contradiction, so we'll get a wrong result. So then we will be able to conclude that our assumption was wrong. So we are getting wrong result. So if we make our assumption right, it means 3 root 7 is an irrational number, correct? So on contrary basis, let us suppose that 3 into root 7 is a rational number. So this can be written, 3 into root 7 can be written in the form of a rational number in the form of A by B, where A and B are co-prime numbers. Co-prime numbers means that is no factor is common in A and B, correct? So we are assuming here that 3 into root 7 is a rational number in the form of A by B, where A and B are having no common factor. Okay, squaring both sides, we will get 63 is equal to A square by B square. 3 3 is 9, 9 into 7, 63, or by cross multiplication 63B square is equal to A square. Here what we find? Here we find that 63 is a factor in left hand side. Here 63 is a factor in left hand side. So both sides are equal, LHS is equal to RHS. So 63 will be factor in right hand side also, means 63 is a factor of A square also. So 63 is a factor of A square also. And you know that 63 is factor of A square. This is possible only when 63 is a factor of A. That is 63 is a factor of A. So let us write A is equal to 63 times of C. You call it relation number 1. Putting value of A in relation number 1. Putting A is equal to 63 times of C in relation number 1. What we get here? We get 63B square is equal to 63C whole square, because A is equal to 63C. So in place of A square, we have to write 63C square. 63 will be cancelled out from both the sides. So we can write that is B square is equal to 63C square. Now in right hand side, 63 is a factor. LHS is equal to RHS. So 63 is a factor in left hand side also. Means 63 is a factor of B square also. Here 63 is a factor in right hand side. So 63 is a factor of B square also. And this is possible only when, if 63 is a factor of B square, it means 63 is a factor of B also. That is 63 is a factor of B also. So now you check these two statements. 63 is a factor in LHS. Okay. Means 63 is a factor of A. Here we are writing 63 is a factor of A. Here we are writing 63 is a factor of B. But what we have written earlier, no factor is common in A and B. So we are getting false result, wrong result. We are getting 63 is a factor of both A and B. Here we are getting here 63 is a factor of both A and B. So we are getting a wrong result, wrong consequence, false consequence. Why? Because our assumption is wrong. It shows that our assumption that 3 into root 7 is not an irrational number, is wrong. So let us make our statement right. That is 3 into root 7 is an irrational number. So it has been proved here. Here we are proving that 3 into root 7 is an irrational number. Hope you have understood it. Very important questions. So hope you will write 2-3 times so that you would have a good command over it. So students, hope that you can do well in your board examination. Just try to understand the concept of this chapter and go through the solution of these questions. All the best for your board examination.